Started. Right. Good morning. We just finished our CL check-in. Today, we're going to finish working on lesson 3, properties of operations. Right. Remember, we started that lesson yesterday. It dealt a lot with working with the distributive property and combining like terms. So we're going to go over that a little bit more. I'm going to go strong over the last couple of slides. And then we're also going to have some time at the end just to practice a little bit more with distributive and also combining like terms. Right. Also, maybe towards the end, depending on how we're feeling, how people are doing with it, we might play a quick game. All right. So let's get started. Find it here. So, we ended off here yesterday, right? We were looking at this question here. It says, which pair of expressions is equivalent? So if I were to label the first one A, the second one B, the next one C, and the last one D, did anybody figure out which of these do they think is equivalent? I'm actually going to just really change it really quick so you can only chat with myself, but too slow. Right? If you're reading the chat, I think Alice already said number 2 before I could change it. So does anybody else agree with Alice that we think number 2 here is the one that has 2 equivalent expressions? All right, so Kevin is also agreeing. Michael's agreeing. Okay, looking at it right now. Okay, give me 1 second, guys. All right, so, okay, good. Sure, Sissy, I'm going to explain in a second. I'm just going to help my daughter put her things inside of a bag. Good. Okay, so we're going to try and figure out what is equivalent by using the distributive. I remember we talked about the distributive. Let's say I'm looking, if you want to distribute, you're going to look for the one that has parentheses. So in this case here, I just see 2 things being added together. Over here, I have a number outside. I have these parentheses. This is the key to telling me that I'm going to have to distribute. And it's lagging. Hopefully it's not too bad. So when I distribute, I'm going to do the thing on the outside of the parentheses, multiply over the parentheses, and multiplied by 9x. So we're going to be 7 times x. I have over here 7 times 7. And then all I need to do is just multiply together the numbers, all right? So I have 7 times 9 is going to give me what? Anybody help me out with that quick math? 7 times 9. Also remember we have a calculator over here on the left-hand side, right? So 7 times 9 is going to give us 63. Thank you for that, Jaden. X, I keep the X there, plus 7 multiplied by 7 gives me 49. Thank you again, Jaden. I keep the Y again here, right? So the X is going to stay, the Y is going to stay. So this says 63X plus 49Y. The left-hand side says 27X plus 45Y. So the only way these would be the same thing is if the number next to the X is matched up, right? This says 63X, that says 27X, so this can't be right. Then you would just check the next one. I'd say, okay, so for this one, again, same thing. I'm going to distribute the 2 times the X, so that would give me just 2 times X, plus I do 2 multiplied by 9y. I'm just going to do it in one step. 2 times 9 is 18. Y, that's the same thing I have over here. 2x plus 18y. So it looks like Alice got it right. And then if just really quickly want to check the other ones to see if we got either of these could be correct. 2 times 15x, this would be 30x. So far it matches up, right? This one is also 30x, but then plus 2 times y, 2y, right? 2y is not the same as 15y, so this one can't be right, right? Also, I already know this is the answer, so I don't have to check them all. but just to give you guys a little bit more practice. And then last one again, I distribute 10 times 4, 40x plus 10 times 5. 50y is what I should get. That's not the same expression, right? Just please let me know if you guys have any questions here. We're gonna, again, practice with distributing more today, right? So after we finish that section, you guys, we're gonna go on to the next part, right? In the next section over here, it's just an activity. I believe it had you reading through an example, writing an expression, probably trying to distribute an answer. So did anybody have any specific questions on any of the questions in this part here? Anything some people were stuck on? You want me to clarify before I move on to the rest of the slides? Okay, thanks, Alfie, no. So really quickly, let me just talk about part C here, all right? So just because we didn't talk about this yesterday, when you're distributing, you're not always gonna have only 2 things inside the parentheses, right? You can have 3 things inside the parentheses, you can have 4 things inside, you can have 5. However, this example here, they gave you something with 3 things inside the parentheses, but it still works the same exact way. You're gonna take what's on the outside of the parentheses and distribute or multiply it by everything inside. So my first term here would be 3x plus, again, I multiply over here, 3 times 3 is 9y, plus, now I have to do it a third time, 3 times 5 is 15, right? So you can have more than 2 things inside your parentheses. In 6th grade, 7th grade, 8th grade, you're really not gonna very often see more than 2 things inside the parentheses. More often than not, it's gonna be the examples you saw before where it's, you know, like 3 times 2x plus 4, something like that. But once you do start getting more into pre-algebra and algebra in high school, you start to see a lot more examples that have multiple things inside the parentheses, right? You might even see something that has up to, like, say, we start seeing stuff that looks like this, maybe. And if you don't know what this means, don't worry about it yet. You might see something like this that has 4 things inside the parentheses. And it's gonna look more confusing, but it still is the distributive property, all right? But hopefully you guys are doing okay with this section here. Nobody's, and it's indicating to me that you want me to go over anything else here. All right, so I'm gonna go on to the next couple of slides. All right, so what this slide is basically telling us is that another way to show whether or not 2 expressions are equivalent is that you can also do that by substituting different values. So they're giving us this big expression here. It's 7 multiplied by x plus 2 minus 21 minus 4x. So mathematically, we can try and reduce and simplify this expression to see how else I could write it, right? I could distribute here first. I could subtract this 21, figure out how to combine these terms, right? But what it's saying here is that what you can also do is you can substitute different values of the variable x to see if they are the same value, right? So for example, we talked about substituting before. Let's say that I know that in this example here, x is equal to the number 2, right? So if x is equal to 2, that means that I'm just gonna replace all the x's that I see with the number 2. So this expression here would actually simplify down to 7 times 2 plus 2 minus 21 minus 4 times 2. Then I would use the order of operations here to evaluate this, right? Remember, we talked about PEMDAS. So I'd say parentheses first. This is gonna be 7 times 4 minus 21 minus 4 times 2. I do my multiplication next. So over here, 7 times 4, 28. I'm keeping this the same, keeping this minus, but now I have multiplication, so minus 8. So now I have 28 minus 1. With the subtraction, I go left to right. So this is going to give me 7 minus 8 gives me -1 here. right? And I'm going through that a little quickly, so if anybody's confused as to what I'm doing here, just let me know and I can stop and try to go over it again, right? So now the idea is, okay, so let's say I'm looking at these four expressions here. Are any of these expressions the same as this expression over here? That's what the question is. So are any of these equal to this one here, right? One way that I can figure that out is, okay, so I know when x is 2, this expression here gives me a value of -1. So why don't I try also taking this x value of 2 and replacing it into these expressions here to see if I get the same value of -1. So let's do it over here. I'd say, okay, so 3 times 2 minus 7, that's 6 minus 7, that does give me -1. Okay, so that's the same value. What about this one over here? If again, I replace this x value of 2, and for this x, I have 2 minus 35, right? That's definitely not equal to -1. So I'm going to say not equal to -1. That one's not right. That's going to be a big negative number. Again, we'll try this one over here. We'll say, okay, so if I replace this one here, sorry if the screen is getting a little crowded, 7 times 2 minus 15, right? 7 times 2 is 14 minus 15. Okay, so I actually got -1 again right here. And then if I try this last one here, I'd say, okay, so 2 minus 7 equals -5. So this one isn't correct, right? But now we might be a little bit confused because we might say, I'm just going to clear the screen, right? After everything that we did, what we actually just discovered is that both this expression here and this expression here both gave us the same value as this guy here, right? But do we think it's possible that all three of these expressions have the same value, that they're all equivalent to each other? Do you guys think that that's possible, that this is equal to this and is also equal to this? All right, I'm seeing some people say no, right? And obviously, if I look at this and I look at this, they don't look like they're equivalent at all, right? So how could I possibly say that 3x minus 7 is equal to 7x minus 15, right? I can't. They don't look the same. This over here has a minus 15. This is a minus 7. This has a 3x. This has a 7x. So what you have to be careful about when you're using this approach, when you're trying to substitute different values, is you can't pick only one value. If you only check one value and that one value works, it could be a coincidence, right? That does happen sometimes where it just so happens, okay, so it looks like for both of these, right, if x equals 2, they both gave me -1. But that doesn't necessitate that they are in fact equivalent to each other. So you actually do have to check two different values if you're using this approach. So that's why over here it said, okay, first check x equals 2, and then you also would want to check a value, different value. You could pick whatever you want. You could pick x equals 4. In this case, they gave us 3. So let's check this one here, right? So if x were equal to 3, I'm going to do the same exact thing I did before. We replace the 3 with both x's. So I'd say 7 multiplied by 3 plus 2 minus 21 minus 4 times 3. And again, we do order of operations first. So parentheses, this gives me 7 multiplied by 5 minus 21 minus 4 times 3. 7 times 5 is 35 minus 21 minus 4 times 3 is 12, right? Almost done. 35 minus 21 is going to give me 24 minus 12. So my final answer, all of that gave me 12. Right? Also, once you guys get into the 7th grade, right, if you're using something like a scientific calculator, what you can do is you can take this entire string here If you were to type this string exactly into your calculator as you see it with the parentheses, your calculator knows the order of operations. It's going to spit out the correct answer, right? So if you've got, I don't think I have one laying around here somewhere. If you've got like one of those, I think it's the TI, whatever, the kind of like dark blue one that they usually use in most schools, you would type this whole thing in there. That's going to give you 12, right? Once you get to high level math classes, we kind of rely a little bit more on the calculator so that you can just do simple stuff faster and get to the harder math. Okay, sorry, I digressed there a bit. Now I do the same thing over here. Let's check x equals 3 on just these two, right? I don't have to check these two because I already know that those don't work. So if x equals 3 for the first one, this expression here would change to 3 times 3 minus 7. 3 times 3 is equal to 9. 9 minus 7 is going to give me 2. Okay, so 2 is not equal to 12, so it looks like that one's out. Let's see if this one works, right? So if I put in a 3 here, I'd say 7 times 3, 7 times 3 is 21 minus 15. Does that give me 12? Mr. Cray may have done something incorrectly here. So 21 minus 15 is going to give me 6. So let's double check our maths back here, right? 7 times 3 plus 2 minus 21 minus 4 times 3. 3 plus 2, 5. 7 times 5, 35. Minus 21 minus 12. 35 minus 21. Okay, I'm not sure how I got 24 here. 35 minus 21 is...
It's 14.
14 minus 12. Okay, got it. So that gave me 2. So this one should be 2, not 12. So the answer actually was the first one, right? So this one over here, we got x equals 2. Sorry, my bad. It's this one here that we can't see right now, right? Let's see. So 3x minus 7 is actually our answer. Sorry about that, guys. Right? So this does seem like a lot of work, though, right? And you're really often not going to do all of this just to figure out if two things are, in fact, equivalent, right? Now, let me show you the faster way that we would do all this here, right? The faster way that I would actually do this is we would just work out the algebra. So I would say, okay, so 7 times x plus 2. Let's try and simplify this expression over here by first distributing. So if I were to distribute this, 7 times x, 7x, plus 7 times 2 is 14, minus 21, minus 4x, right? Now, I need to combine like terms. So we kind of talked about this briefly yesterday. Basically what happens is I'm going to look to see, okay, what x's do I see? What numbers do I see? So I'm going to use different colors here, right? I see that I have a 7x, and when you're combining like terms, you're also going to take the sign next to it. So I have a minus 4x, right? So I can basically rearrange these and say 7x minus 4x. And then let's look at what I have left over. I still have a plus 14 and a minus 2. So 7x minus 4x, I'm basically just rearranging these things, right? Minus 21.
Minus 21.
There we go. So 7x minus 4x. This part here simplifies down to 3x. 14 minus 21 gives me a minus 7. All right? So 3x minus 7 was in fact the same thing that we got over here. All right, so again, this would be the faster way to do this approach, and it does require just a little bit more comfortability with algebra. But this method here is just something else that they're showing you that can also work. All right. Any questions on this slide here? This is probably the most complicated slide of this lesson. All right, so this next slide here is basically just explaining everything that I went over with you guys. All right, so if you don't feel like going back and watching the recorded video and you want to see how exactly they did all that, that's given to you here. So this is just replacing x equals 2 into this expression, this one, and replacing x equals 3 as well. All right, so over here, we have another example where we're looking at an expression. So I have 2 times x minus 3 plus 4. I want to figure out which of these 4 expressions is equivalent. So I changed the chat to host only. So I just want you guys to tell me in the chat, which one do you think is the correct answer? Number 1, number 2, number 3, or number 4? Again, ideally, this is something that we did yesterday. If you didn't get to it yesterday, just try and work it out quickly now. Okay. Okay, good Sissy, good Michael. I gave a couple more people time to think about it. Okay, right, Jing Hao. Yep, AJ, you're right. All right, so do I have a volunteer that wants to actually write out and show how we get the answer here? Mathematically, what would we do to show that these two are actually equivalent to each other? So I'm going to turn on annotations. And can I get just a volunteer that wants to draw out on the screen how they got their result? AJ, sure, go ahead.
I can't draw on the screen.
Oh, give me a second, I thought I turned it on. You should be able to right now, I enabled it. Try again. Can anybody else check if they're able to annotate? Okay, Alfie's able to annotate. It's still not working for you, AJ?
No, it's not working for me.
Okay. Anybody else that wants to show it quickly, or I can show it? Anthony, you're writing in white.
Oops.
Okay, so some people are having trouble editing. I'll just go over it so we can get through a little bit faster, right? First thing that I would want to do here is work. Can somebody tell me what my first step would be? Starts with a D. So I'm going to distribute, right? So first thing is I see this number with parentheses. That's a key sign that you're going to have to distribute. So 2 multiplied by x, 2x, minus 2 multiplied by 3, 6, right? You're going to notice that if you have a minus, it just changes to a minus. If it's a plus, it stays a plus. And then over here, I still have this plus 4. So to simplify this, all I really do is I have, okay, so 2x minus 6 plus 4, right? 7th grade, you guys spent a lot more time dealing with negative numbers, and there's a bunch of rules for when you're adding and subtracting negative numbers. But the way that you got to think about this is like, okay, so let's say you owe somebody $6 and you pay them back $4, you're still going to owe $2. So -6 plus 4 is -2, right? So our answer, a couple of people got it right in the chat, was 2x minus 2. Right, any questions there before we go on? Okay, thank you for the feedback. All right, so this next one I just want to actually explain because I know it did gloss over some of these terms here and it might not have actually fully explained them for you guys. All right, so it's saying here that we've got a couple of different properties, and a lot of times in math we use properties without even knowing what they actually are named. So this here is kind of putting names to things. So let's try and figure out the ones that we know first. All right, which one of these here do you guys think is the distributive property? The first one, the second one, the third one, or the fourth one? And just let me know in the chat. So again, we'll say the top one is number 1, number 2, number 3, number 4. Which one is going to be the distributive property? Okay, so you're correct, Sissy. All right, so what Sissy thinks number 3 is a distributive property, right? So how can we tell that it's the distributive property? By looking at it, right? Remember, a key thing with the distributive property is that you're going to see parentheses, and then after you distribute, you don't see parentheses anymore, right? So what happened here is you distribute 7 times 3 gives you 21x, 7 times 4 gives you 28y. So that's a case where they distributed to figure out and simplify this, right? Now, let's see something else that I know we talked about. We also talked about combining like terms. So combining like terms is when you're taking different things with x's or different numbers and you're adding them together. Does anybody think they see an example here of where we're combining like terms? So maybe we added together some x's, or we added together some y's or some numbers together. Yep, that's correct. Okay, good. So people in the chat are typing. If you said number 2, you are correct, right? That is combining like terms, right? The reason we know that it's combining like terms is I see, okay, so 4y minus 9y, and on the right-hand side, I still have the x here, but they took together this 4y minus 9y, and now they have a minus 5y. So they combined our y's together, right? That's what combining like terms is. There's no way here to combine this x with this 5y because they're not like terms, right? It's kind of like if we said that x's represented apples and y's represented oranges, you can't then at the end say, you know, combine your apples and your oranges because you're counting 2 different things. That's the best way to think about it. So now we're left with our last 2 properties, the commutative property and the associative property, right? So commutative property, think about the first part there is commute. So like we might say that somebody commutes to work or somebody commutes to school. Commuting means that you're moving from one place to another, right? So can anybody take a guess onto which of these 2 do you think is the commutative property where something is moving? Correct, Alice, right? If we look at number 4, number 4 has 7y plus 6x, so the y is first followed by the x. And then this one over here, the 6x is first followed by the 7y. So basically what happened is the x's and y's switched places, right? That's an example of the commutative property, right? And this works with addition. It also works with multiplication. I could say something like 6 times 3 is equal to 3 times 6. Yes, Alice, you're correct. So last one is the commutative property. Again, commutative property just means that you can move things around, right? Also, we kind of did a commutative property earlier. Remember we had an expression, it was, I don't remember what it was exactly. It looked something like 7x maybe minus 21 plus, I don't know, let's say 4x minus 3. It wasn't exactly this, but let's say this was my expression. The commutative property lets you rearrange things, right? So what we could do is I could say, okay, so move the 4x second, swap the 21 over here, the 3. So commutative property just lets us move different things around. When we think about the associative property, the last one, think about associate. So if you're saying that two people are associated with each other, that kind of means that they know each other. So, and maybe they form like a group together, right? The way that we group things in math is with parentheses. So when we're talking about the associative property, we're talking about kind of associating different things together with parentheses. So in this case over here, I have 7x plus 2x plus 12. So at first, the parentheses are around the 7x plus 2x. And then over here, I still have the same 3 terms. I have 7x plus 2x plus 12, but they shifted the parentheses from around the first 2 terms to around the second 2 terms, right? That's what this associative property means. So let me give you an example with just numbers. Let's say I gave you the expression 3 plus 4 plus 5. So addition and multiplication both have the associative property. So if I was to try and add these up, I could either first do it like this. I can add, okay, so 3 plus 4 gives me 7 plus 5. 7 plus 5 is going to give me 12. Or I could do it like this. I could say 3 plus 4 plus 5, add the 4 and 5 together first and say, okay, so 3 plus 9 still gives me 12, right? That's the associative property. It basically means that you can kind of move parentheses around and do things in a different order if you're dealing specifically with multiplication or addition, right? Any questions on this slide here? Because again, a lot of times in math, here are properties that you guys should have learned in prior grade levels, but a lot of people just kind of assume that everybody learned it once, they memorized it, they know it, but you're gonna find a lot of students do forget just the names of them, right? You might remember, okay, yeah, so sure, I can, swap the order of these things because I'm adding, or yeah, I can move these parentheses around, but you just might forget the names of what we call those things, right? So hopefully this helps so that you guys remember that a little bit more. Right, so we're up to the summary. That means we're pretty much done with the lesson. Just remember the key things that we learned today. We were talking about the distributive property. We were talking about combining things with like terms and just kind of figuring out when expressions are equivalent, right? And all those properties that we just saw on that last page, commutative, associative, distributive, combining like terms. These are all things that you guys are just going to be using naturally as you move forward in your math careers, right? You might not always refer to it by name, but you should know what it means to distribute something. You should know what it means to combine like terms, right? So what we're actually gonna do, we've got a little bit more than 10 minutes left, is I thought that we could play a quick game together.